So acid-base titration, this is a little bit different than what we did before. A 10 milliliter solution of calcium hydroxide is neutralized by 23.30 milliliters of 0.02000 molar nitric acid. What is the molarity of calcium hydroxide? Okay, so now we're calculating molarity over here. Again, as usual, we'll go ahead and write our equation. So calcium hydroxide plus nitric acid gives calcium nitrate and water. Okay, to balance the equation out, we need to have 2 of nitric acid. Okay, all right, and then for calcium hydroxide, we have 10 milliliters, okay, which remember converted into liters, and we have the liters of HNO3, so that's 23.30 times 10 to the negative 3 liters, and the molarity is 0.02000 molarity, and we're supposed to find out the molarity of calcium hydroxide. Okay, our strategy always, okay, have a strategy in mind. So we find the moles of HNO3 using the molarity, then we'll find moles of calcium hydroxide, and then from there we will calculate molarity, okay, using the volume that's given to us, okay, because once we have the moles of calcium hydroxide, that should be easy to do. All right, so moles of nitric acid, this must be getting a little boring because it's the same thing again, 23.30 times 10 to the negative 3 liters times 0.0200 moles over liter, and this is for nitric acid times the moles, and now we have moles of HNO3. So moles of nitric acid goes down here, moles of calcium hydroxide goes on the top, and we have 2 moles of HNO3 for every 1 mole of calcium hydroxide. Now that we have moles of calcium hydroxide, okay, moles of nitric acid are gone. Now to get molarity, you just need to actually divide it by the volume, because this is moles, and so you need liters down here, which is 10.00 times 10 to the negative 3 liters. If this empty space is bothering you, then you can go ahead and write 1, but otherwise you don't really need to, because really you're dividing moles by liters. Okay, that's all you need to do. And so this is 0.0233 molarity, okay, of calcium hydroxide. If you will see in the few problems that we've done, and even in this one, you don't need the molar mass of anything, okay, because you're already working with moles of everything in a solution. You don't need the mass, okay, of any of these compounds, which really is quite nice, okay, because you don't need the periodic table for these calculations. Okay, next problem then is 15.00 milliliters of sulfuric acid is neutralized by 32.44 milliliters of 0.00986 molar sodium hydroxide. Question is, what is the molarity of sulfuric acid, and then what is the molarity of the sodium sulfate that is formed? Okay, so as usual, we write the equation first. Sulfuric acid, that is neutralized by sodium hydroxide. Acid plus base gives you salt and water. Our salt is sodium sulfate, and then of course we have water. Let's see if the equation is balanced, and it is not. We have 2 sodiums, so that, and then we have to have 2 waters. Okay, here. Writing the information that we need is 15.00, again 10 to the negative 3 converted into liters right away, and 32.44 times 10 to the negative 3 liters of 0.00986 molar. For those of you who want to work a different way, you can also go ahead and calculate the moles right from underneath the sodium hydroxide. So if you multiply the 2, which really is what you're doing to find the moles, you will then get 0.0003198584, which you can round off to then 3.199 times 10 to the negative 1, 2, 3, 4. Okay, and that's the moles, and that's what you would have gotten to begin with anyway. Okay, so let's go ahead and start from there. 3.199 times 10 to the negative 4, and this is moles of sodium hydroxide. And now we will go ahead and find the moles of sulfuric acid. So moles sodium hydroxide to moles sulfuric acid, and the mole ratio is 2 moles of sodium hydroxide for every 1 mole of sulfuric acid. Now that you have moles of sulfuric acid, again you just need to divide that by the volume of sulfuric acid, which is 15.00 times 10 to the negative 3 liters, and that gives us 0.106, I think I missed a 0.01066 molar, okay, solution of sulfuric acid. So that's the molarity of sulfuric acid. The second part is molarity of sodium sulfate. Okay, so to find the molarity of sodium sulfate, you need to go from moles of sodium hydroxide to moles of sodium sulfate, and then again to molarity, okay, using total volume, okay, that we will have. So moles of sodium hydroxide we already have, which is 3.199 times 10 to the negative 4 moles of sodium hydroxide times, and then do the mole ratio of moles of sodium hydroxide to moles of sodium sulfate, and that is 2 moles of sodium hydroxide to 1 mole of sodium sulfate. Now regarding the total volume, that's going to be the 15.00 times 10 to the negative 3 plus 32.44 times 10 to the negative 3, okay, liters. That's what it is, and this is actually 0.04744 liters, okay, if you do the addition of that. But anyhow, what this is the addition of both sulfuric acid and the sodium hydroxide, okay, and the final answer for this is then 3.371 times 10 to the negative 3 molarity. Now some of you may think that we have water also as a product, and why are we not using that as a volume? And that water is going to be so small, because if you look at the molarity of sodium sulfate here also, it's a very, very small amount, okay, that we have formed. So the amount of water that you form as a product is going to be so less that it's not going to matter, so we don't need to add it to the total volume of solution that we have.